So the next topic to be discussed is storage classes in C language. So a storage class is going to define the scope and longevity of the variable. So scope indicates what is the range. Okay, so if you define a variable, so that particular variable can be accessed, whether it can be accessed by throughout application and throughout a function and throughout across the applications. Okay, means storage class is going to define the scope of a variable, means the scope is going to indicate what, whether it is function level, application level, and all applications, whether it can access all applications. It can be accessed by all applications, means so it is going to indicate what, the scope of a variable. Scope of a variable. Scope is going to represent the range of the variable, how long, where it can be accessed, in which location it can be accessed. Means whether a variable can be accessed within a function or within a application. So within a application, within a application, within a function, there is a lot of difference between within a application and within a function. Means the application may be consisting of several functions. So if you want to declare a particular variable inside a function, that what happens here, that particular variable becomes local to that particular function, and it can be accessed by within the function only. Okay, based on scope of a variable and longevity of the variables, the storage classes are divided into mainly 4 categories. What are the 4 categories? First category is automatic variable. Automatic variables. Second one is static variables. Third one is register variables. Fourth category is external variables. Like this, variables are divided into 4 categories: automatic variables, static variables, register variables, and external variables. So the differences I will show very clearly. Okay, so automatic variables, as their name says, automatically they are created within a function, and whenever a function is exited, what happens, the life of the automatic variable will be collapsed. The life will be vanished here. Means within a particular function, a automatic variable can be accessed. So automatically when a function is created, the variable is created, and whenever the function is exited, what happens here, the life of the automatic variable will be vanished. Suppose here I declare a variable like this: void main. I may declare a variable like this: integer a equal to 10. A equal to 10, printf %d and say a, and you say call like this. So whenever main function is started, what happens, automatically a is created and 10 is initialized to a. So in the next line, what I am doing here, it is going to print 10. So in the next line, what I am doing here, I am making a call to which function? Call function. Call function is itself is a function name. So I am calling call function. Immediately the flow of execution is shifted to call function like this. So here it is going to perform some actions, and whenever control encounters closing bracket of call function, it is going to return to the main function. Okay, and when it is returning main function, what happens here, it does not know about a. Okay, means whenever main is created, a is created, and whenever function is exited, control is jumping to call function, this a equal to 10 will be destroyed. Because of that reason, they are called as automatic variables. Automatically they are created and they are destroyed at the time of function exiting. Okay, that means in between function calls, they are not going to retain any values. in between function calls, means in between main function and call function, they are not going to retain, they are not going to store their values. Okay, so this is about automatic variables. So automatic variables, how they can be declared here? By prefixing auto keyword before the variable name, a automatic variable can be declared. Okay, that means by default a variable is declared within a function becomes what? That is automatic variable. No need of specifying any clear cut name. Automatically they are declared, they are specified as what? Automatic type. Okay, just I will show one example here, just you have a look. So here is a small program which is going to show demonstration of automatic variables. So here I have written two functions. So what are the functions here? One is the main function, and another one is call function. Function name is call. Okay, so when a call is made, here I am calling what? Call function. Directly what happens here? The control is shifted to call function. Here what happens here? A is initialized to 0, A equal to A plus 1. So A equal to A plus 1 means what happens here? Automatically A value is printed, A becomes 1, and whenever control is going back to main function, the A will be destroyed. A will be destroyed. A will be destroyed and the control is shifted to call of next line. And whenever the control is coming back to call function, what happens here? A new set of A will be created again. Old value is erased. Okay, freshly A value is created with 0 initialization. So in the next line what I am doing here? A equal to A plus 1 means 0 plus 1, 1. Previously it has printed 1 and this time also it will print 1. Next time also it will print what? 1. Every time when the control is coming to call function, the A value will be created and destroyed. Created and destroyed. And when the control is coming to call function, A is created, and when control is going back to main function, A is destroyed. A is destroyed. So every time A is created and destroyed. Every time A is created and destroyed. That is why the output of this program will be what? 1, 1, 1. Just to look at this, I will show. The output is 1, 1, 1. One, one, one. Okay. Of course, it is not visible, no? Just to look at the output. Out 1, 1, 1. Means every time A is created newly and the value of A is incremented by 1, finally it prints the value of A like this. See, just I will show the program line by line. Call is invoking. Okay, by this what happens here? A is initialized to 0. A equal to A plus 1 means 0 plus 1. 0 plus 1 it is 1. It prints A value, 1 is printed. And when control is coming back, going back to main function, what happens here? The A will be destroyed. A value is destroyed. Second call is executed. Now when second call is executed, what happens again? Control will come to call function. A new set of A is created again. Old value is erased because it is automatic. Automatically created, automatically destroyed. Because of that reason only they have been named as automatic variables. Again fresh A is created and again A equal to 0 and A equal to A plus 1, 0 plus 1. Again 1 is printed. Again control is going back to main function. In the main function again call function is executed, call statement is executed. When call statement is executed, again control will come to call function. Here again one more A is created. 3 sets of A's First A, second A, third A. So this is third time A is created. A equal to A plus 1, 0 plus 1. And like this. 1, 1, 1. Every time when control is coming to call function, a new A is created, and whenever the function is going back to call function to main function, A is destroyed. Okay, because of that reason, every time 1, 1, 1. Every time A is reinitialized to 0. That is about static. That is about automatic variables. And next, when coming to static variables. So in case of static variables, the story is different here. So how the story is different, I will explain. And if I declare a variable as static, then what happens? Just you observe the difference. I will say static. Now it is 1, 2, 3. Means what makes the difference here? Previously, I have created automatic variable. This is auto. If you are not specifying anything, what happens by default? It becomes automatic variable. 1, 1, 1. Okay. So the automatic variables will not be retaining values between function calls, whereas static variables will be retaining their values between function calls. Means whenever a call is made to call function, what happens here? A new A is created, A equal to 0, and A equal to A plus 1, means 0 plus 1, 1, and A value is printed, means 1 is printed. And when the control is going back to main function, what happens here? It is going to store 0 in the registers. Okay, 1 is preserved, 0 plus 1, 1 has been stored in the registers. And next time when second call is made, what happens here? Again control will come to this function, call function. It A will not be reinitialized, because this is static. You better make it as static. See, directly A equal to A plus 1. Directly static integer A equal to 0 is not executed. 1, 2, 3. Previously, what that is? If I say automatic, every time this statement is executed. Integer A equal to 0, A equal to A plus 1, 0 plus 1, 1. Again A equal to 0 is executed because it is automatic. Again A equal to 0, A equal to A plus 1. So it has printed what? 1, 1, 1. Every time A equal to 0 statement is executed. And if I say static, what happens here? It is going to preserve the values between function calls. Yes. See, call is made. In the call, A equal to 0 is initialized only once. A equal to A plus 1. And second call is made now. Now when second call is made and when control is coming to call function again, what happens here? The previous A value is utilized. Okay, the previously stored value is what? 1. Now A equal to A plus 1 means 1 plus 1. This becomes 2. 2 is printed. And again control will go to main function. So in the main function also same story, means call is executed again. So when call is executed, again control will come to call function. So in call function, so the previous value of A is used. The previous value of A is what? 2. First time it is 1, second time 2, third time, this is the third time. So 2 plus 1, this becomes 3. So what happens here? A value is printed. 1, 2, 3. This is the difference between automatic and static variables. Automatic variables do not preserve the values between function calls, whereas static variables will be preserving values between function calls. Means the scope of an automatic variable is what? The scope of automatic variable is within the function only. So when a function is created, a automatic variable is created, and when a function is exited, automatically the automatic variable is destroyed. But in case of static variable, what happens? They will be preserving their values between function calls, and the duration of a static variable is what? Entire application. So in the entire application, it is going to store their values. Means in between function calls only, they are going to preserve the values. Means static variables are different, automatic variables are different. That means the static variables scope is very high compared to automatic variables. Okay. So the next topic to be discussed is register variables. So the next topic to be discussed is what? Register variables in static storage classes. So as its name says, a register variable is stored in the CPU registers. Normally, when you are giving a value to a variable, the variable will be stored in the primary memory, RAM. Okay. So from the primary memory, what happens here? When you are printing the values, the compiler's duty is to fetch the values from primary memory. So whenever the compiler is fetching values from primary memory, it may take little bit delay. Okay, because in the primary memory, many locations, several storage locations are there. Out of them, it has to fetch particular value. So to fetch a particular value from millions of storage locations, it may have little bit delay. Okay, for avoiding that reason, to overcome that drawback, so we can tell the compiler to store some values in the CPU registers. So as the CPU is going to contain very limited number of registers, accessing a value from CPU register becomes very easy when compared to accessing a value from primary storage. That means if a variable is declared as register, the compiler does not store its value in the primary memory. Where it is going to store? The register variable value will be stored in the CPU registers. On CPU also, we are going to have some limited number of registers where we can store limited amount of information. That means the values which we are going to access frequently can be stored in CPU registers. So that what happens here? Accessing of a CPU variable, so a register variable becomes very fast when compared to accessing of a variable from primary memory. That means to store a value in CPU registers, that variable must be defined as what? Register. That variable must be defined as register. So that what happens here? The compiler is going to store that particular register variable in the CPU registers. Okay. So that is about registers category. That means only for fast accessing of data items, few values can be stored in the CPU registers. Okay, for fast accessing of the data, for fast accessing of the data retrieval, you can ask compiler to store the values in the CPU registers. So that what happens here, within no time the items will be retrieved when compared to accessing values from primary storage. Okay, so how can you do it? Okay, so to do that task, just to prefix the variable name by register keyword. Okay, so how it can be done, just I will show. Just you have a look. Just I will write the program. After that I will execute it. Void main. Here you say, just use a register integer a. Use for integer, sorry, this is a equal to 1, a is less than or equal to 10, a plus plus. You print if the elements. This is about register variables. A value just I am printing, I am taking a value in the loop, or directly you can use a value hash include stdio.h void main register integer a. For a equal to 1, a is less than or equal to 10, a plus plus. Printf this is about register variables. 1 to 10 numbers are printed using registers. Here just I have declared a as a register variable, and I have printed a value for 10 times. This is one program, and using scanf also you can assign a value into a variable. Okay, so just for fast accessing of the data, so you can declare a variable as register type. So in small applications you cannot feel the difference here. So in real-time applications, so accessing data, so accessing a register variable becomes very fast when compared to normal automatic and static variables. Okay, so this is about register. So just for fast accessing of items, we can make use of register variables. The next last category is external variables in the storage classes. So if you want to use a particular variable across the applications, okay, you can declare a variable external. So once it is declared as external, so that can be used by any number of applications. So 4 types of storage classes we have discussed. First category is automatic variable, static variable, register variable, and external variable. Okay, so automatic variable is created whenever a function is created, and whenever a function is executed, automatically variable will be destroyed, and they do not preserve their values between function calls. And static variables are especially for multiple functions. That means if you want to access a particular variable between, if you want to retain a value between function calls, use static variable. Okay, so every static variable is initialized only once, and whenever function is going back to called function, it is going to preserve the values. And when the function is coming back to same function, what happens here? The preserved value will be utilized. And what is a register variable? Register variable is a variable whose value will be stored in the CPU registers. So that what happens here? Accessing of that particular variables becomes very fast when compared to accessing of a variable from primary storage. And if you want to use a particular variable by many applications, you better use external variables. Okay, so in the next video session I will discuss how to use external variables that I will show. Okay.